Hi class, so finally we enter the chapter 3, which is gravitation. So today we are going to learn about the first subtopic in this chapter, which is 3.1 Newton's universal law of gravitation. So in this subtopic we will cover three different parts, which is first one, solving problem by using Newton's universal law of gravitation. The second one, which is part B, we will learn about centripetal force, and the last part is how to determine mass of Earth and Sun. But in this video, we will only cover about part A and part B. Okay. Okay class, but before that, let's take a look on the definition of the Newton's universal law of gravitation. Okay class, let's take a look on this statement. Gravitational force is directly proportional to the product of masses of two bodies. F is directly proportional to the product of mass m1 times with m2. And the second statement is gravitational force is inversely proportional to the square of distance between the center of two bodies. Square of distance means r square. Okay, r is the symbol of distance. Inversely proportional, so that's why F is inversely proportional to the 1 over r square. Okay, so Newton said that there is the gravitational force between each two objects. Okay, so this is two body or two object. So the first one is m1 and the second one is m2, mass 1, mass 2. So for the second statement, it said that square of distance between the center of two bodies. Center of two bodies. So this is the center, and from here to here is r, the distance between two bodies. Okay. So from this relationship, we have F is directly proportional to the product of masses of two bodies, and F is inversely proportional to the square of distance between the center of two bodies. Then we have F is directly proportional to m1 times with m2 divided by r square. But Newton add up the G value, which is the gravitational constant. So the final formula is F is equal to G m1 m2 divided by r square, which is G constant is always 6.67 times with 10 to the power of negative 11 and m square per kg square. This value of G is constant, always same. Okay class, let's take a look on the first part, which is solving problem by using Newton's universal law of gravitation. Okay class, so let's move to the first part, which is part A, solving problem involving Newton's universal law of gravitation. So in this part, we will cover four important things, which is the first one, two stationary objects on Earth. Means the gravitational force between two stationary objects, two objects at rest on Earth. Okay, so this is object A and this is object B on the Earth. So for the second thing is object on the Earth's surface. Object on the Earth's surface means that we need to solve problem, solve the gravitational force between the object and the Earth. So this is object and this is Earth. So we need to find the gravitational force between these two things, and just now we need to find the gravitational force between two objects on Earth. Okay, this is the first and this is the second one, and the third one is we need to find the gravitational force between Earth and satellite. Okay, so the third one is gravitational force between Earth and satellite. Okay. And the fourth one is we need to find the gravitational force between the Earth and the Sun. Okay, so these are 4 important things that we will cover in part A. Okay class, so the first thing is gravitational force between 2 stationary objects on Earth. So for the example, this is 2 stones and the gravitational there is gravitational force between them, and the higher the mass of object, the higher the gravitational force. Means that if the object has the bigger mass, then it will have the bigger gravitational force. And the second one is the further the distance between objects, the lower the gravitational force. If the object has the bigger distance, then the gravitational force will be low. If the object has a smaller distance, then the gravitational force will be higher. Okay, this is distance. Okay class, so let's take a look on this example. Okay, a 50 kg student and 85 kg student have 10 meter distance between them. Calculate the gravitational force. So we need to find the gravitational force. So the formula to find the gravitational force is F is equal to G m1 times with m2 divided by r square. Okay, so m1 here is 50 kg, right? And m2 is 85 kg. We have r, the distance is 10 meter. So we just need to transfer the information. So what is G? G is constant, right? Just now I said G is 6.67 times with 10 to the power of negative 11 times with m1, which is 50 kg, times with m2, which is 85, divided by r square. R is 10 square, and the final answer we will get 2.83 times with 10 to the power of negative 9 Newton. Okay class, so this value is very small. 2.83 times with 10 to the power of negative 9 means that 0.00000000283 Newton. So this value is very small. Okay, so if the gravitational force is small, it means the object on the Earth cannot feel that gravitational force because the gravitational force is very small. Okay class, let's move to the next point, which is the gravitational force between object on the Earth's surface. Means that the gravitational force between the Earth and the object on the surface of Earth. Okay, so this is the object on the surface of Earth and this is the Earth. Okay, so this is the Earth. So just now the formula is F is equal to G times with mass 1 times with mass 2 divided by distance, right? The distance is mass from the center of the Earth and the center of the object. Okay, so the distance from the center of the Earth and the center of the object, we will have the radius of the Earth. Okay, the distance between the center of the Earth and the center of the object is equal to the radius of the Earth. So the radius of the Earth, we label it as capital R, and the capital R, the radius of the Earth is constant, which is 6.37 times with 10 to the power of 6 meter. So this value is fixed. Okay, to find the gravitational force between the object on the Earth's surface and the Earth, we need to use this formula. F is equal to G m1 m2 divided by capital R square. Okay class, so this is the example of question to find the gravitational force between the object on the Earth's surface and the Earth. Okay, so the object on the Earth's surface in this question is this durian. So calculate the gravitational force between a durian and the Earth. Okay, so the mass of durian is given, which is 2 kg. Mass of Earth is 5.97 times with 10 to the power of 24 kg. This is also a constant value. Okay, so the distance between the center of durian and center of Earth is 6.37 times with 10 to the power of 6 meter. This is what? This is the radius of the Earth, which is capital R. So by using this formula, F is equal to G m1 m2 divided by capital R square. We have 6.67 times with 10 to the power of negative 11, which is constant G, times with m1 2 kg, and times with mass of Earth 5.97 times with 10 to the power of 24 divided by R square, capital R square, which is 6.37 times with 10 to the power of 6 square. You just need to use the calculator to find this answer. And the final answer, we have 19.63, and the SI unit is Newton. Okay class, this is the gravitational force between the Earth and satellite. So the Earth and satellite, okay, the formula is just the same. F is equal to G m1 m2 divided by R square. But okay, R here is from the center of the Earth and the center of the satellite. So R is here. So how to calculate? So R is equal to R, a capital R, times with H. R, small r, is equal to capital R times with H. Capital R is the radius of the Earth, plus with H, the height, and we will have the total distance from the center of the Earth to the center of the satellite. So the formula is F is equal to G m1 m2 divided by R square, or G m1 m2 divided by capital R plus H square. It's just the same. But to find the G, which is gravitational acceleration, we need to use this formula, which is G is equal to Gm divided by R, capital R plus H square, or G is equal to Gm divided by total distance square. Okay, so G is constant, G constant 6.67 times with 10 to the power of negative 11, right? So M is capital M, which is mass of Earth. So this is how to calculate the gravitational acceleration on the satellite. Okay class, let's take a look on this example. A radar imaging satellite orbits around the Earth at a height of 480 km. What is the value of gravitational acceleration at the position of satellite? Okay, so this is the Earth and this is the satellite. Okay, it has the height of 480 km. So height, the H is 480 kilometer. Okay, so the radius of the Earth is R, capital R is equal to 6.37 times with 10 to the power of 6 meter. Okay, so we need to find gravitational acceleration, right? So the formula to find gravitational acceleration is G equal to Gm divided by R square, or G is equal to Gm divided by R plus H square. Okay, so we know that G is 6.67 times with 10 to the power of negative 11 times with M, capital M is the mass of Earth, 5.97 times with 10 to the power of 24 divided by R plus H square. R is 6.37 times 10 to the power of 6 plus H. H is 480 km, right? So you need to transfer it into meter. So 480 km times with 1000, and you will get the distance in meter. Okay, so this is, you need to square kan je lah. So the final answer is, we have is 8.487 m to the power of m per second to the power of negative 2. Okay, this is the last thing in part A, which is the gravitational force between Earth and Sun. Okay, so the formula that we use is same. F is equal to G m1 m2 divided by r square. And how to calculate the gravitational acceleration of the Sun is G is equal to Gm divided by r square. The mass is also, we need to use the mass of the Earth, which is capital M. Okay, and the total distance from the center of the Earth and the center of the Sun is R is equal to 1.5 times with 10 to the power of 11 meter. So the distance from these two objects is always constant, fixed. Okay class, let's move to the part B, which is centripetal force. So what is centripetal force? Centripetal force is force of object that moves in a circular motion. Means if we have the Earth and we have the satellite is moved in a circular motion. So from this situation, move in a circular motion, we will have the centripetal force. Okay class, so the formula for the centripetal force is F is equal to mv squared divided by r, which is F is centripetal force, m is mass of the object that move in a circular motion, v is the velocity of the object that move in a circular motion, and r is the distance between these two objects. For this example, between Earth and satellite. And so, while A is equal to v squared over r, A is acceleration, centripetal. Okay, centripetal acceleration is A is equal to v squared. V is linear speed, same velocity, and divided by r, the distance between Earth and satellite. Okay class, so for example, a satellite orbiting the Earth at height 480 km, linear speed of satellite is 7.62 times with 10 to the power of 3 meter per second, and R, capital R is equal to 6.37 times with 10 to the power of 6 meter, which is always constant. What is the centripetal acceleration? So the question asks us to find the centripetal acceleration. So first we need to determine the formula of centripetal acceleration. So the formula is A is equal to V square over R. Okay, so V is the velocity. Linear speed of satellite is 7.62 times with 10 to the power of 3. So 7.62 times with 10 to the power of 3 square divided by R. So what is R? R is the total distance between the Earth and satellite. So R is R plus H, right? R plus H. So 7.62 times with 10 to the power of 3 square divided by R is 6.37 times with 10 to the power of 6 plus with 480 kilometer, but you need to times with 1000 so that you will get it into meter. Okay, because meter is the SI unit for distance, length. Okay, and the final answer we have 8.48 meter per second to the power of 2. Okay, so we already finished about the part A and part B. Inshallah, part C we will have in the next video. Okay, so that's all for today.